Hi all, welcome to our channel. I'm back with another interview question, that is product of array except self. So given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. Okay, for example, let's take this array nums 1 2 3 4. Then the answer array should be like this: 24, 12, 8, 6. Let me explain how. So at 0 index we have 1. So the answer of 0 should be product of remaining elements, that is 2 into 3 into 4, that is 24. In similarly, the element at first index should be product of 0, 2, 3, that is 1 into 3 into 4, 12. So like that we should return an answer array such that answer of I is equal to the product of all elements of nums array except nums I, that is self. Okay, simply product of array except self. So here the constraint is without using the division operation. Okay, so for this problem I am going to show you three approaches how to solve this problem uh, using three approaches. The first approach is naive brute force approach. So in this approach, for each position I, we iterate through the entire array and multiply all elements except the one at position I. This is the first approach. The second approach is prefix and suffix arrays. We build products from left and right and then combine. This is the second approach. The third approach is space optimized solution. We use result array for prefix and then multiply by suffix on the fly. So this is a optimized solution, space optimized solution. These are the three approaches I'm going to show you to solve this problem. Okay, I'm going to make three parts for this solution. In the first part, I will show you the approach one, how to solve this problem using approach one. And in the part 2 video, I'm going to show you the second approach, and in part 3 video, I'm going to show you approach 3. Okay, for this video, let me show you the first approach. Okay, how to solve the given problem using the first approach. Okay, let me create a function const product array except self. Okay, which takes, it's a function which takes array as an argument. Okay, and then inside this, let's create a result array. Let's create result array and initialize with ones. Result equal to new array of size nums dot length. This is the array which we passed. Okay, and then fill with all ones. Why? Because one is a multiplicative identity. Okay, we use 1 because multiplying by 1 doesn't change the value. Okay, now let's take two loops. As I said, right, in the approach 1 we are going to multiply for each position I, iterate through all elements of array and then multiply. Okay, for that let me take the first for loop, that is outer for loop, to iterate through each array element. Okay, let I equal to 0, I less than nums dot length I plus plus. Okay, and then we'll take another for loop, that is inner for loop. This is to multiply all elements except at position I. Okay, let j equal to 0, j less than nums dot length j plus plus. Okay, now so inside this, what we're going to do is we'll add a condition to skip the element at position I. Why? Because we don't want to uh, include the element at a position I. That is accept, right? I mean the product accept the self. So for that we are going to skip the element at position I. For that, let's add a condition if I not equal to j, then only we are going to multiply current result. Otherwise, we skip. Okay. For that, I'm using the condition here, and then result of I, result of I are equal to nums of j. Okay. So here, what we are doing is we are multiplying current result by element at position j. So this is going to execute for all iterations inside the for loop, this inner loop. Okay, and then at the end of the both for loops, we are going to return result array. Okay, why? Because we are storing the product of all elements except the self inside result array. Okay, now let me show you the output using one example. Okay, so this is the first approach. Let's take one array const nums equal to 1, 2, 3, 4, and then let's call the method and pass this array, and then for which we are going to pass nums. Let's run and then see. Let's run and then see the output. We see here 24, 12, 8, 6. Let's cross check here. So at position I, the product should be 2 into 3 into 4. 2 into 3, 6, 6 into 4, 24. Correct. At index 1, the product should be 1 into 3 into 4. That is 1 into 3, 3, 3 into 4, 12. Similarly, the product at index 2 should be 1 into 2 into 4, 8. And then at 4, at index 3, it should be 1 into 2 into 3, 6. So, okay, it's working fine. This is the first approach we used to solve the problem. Here, the cons, we have a cons here. That is, we have a drawback here. Though we are achieving the solution, it's slow for large arrays, and the time complexity is big O of n square since we are using 2 for loops. Okay, and this approach is insufficient due to repeated calculations. Okay, I'm going to show you the approach 2, how to solve this problem using approach 2 in the next video. Thanks for watching. If you like the video, please like, share, and then subscribe.